right, so it looks like we are live here. So welcome to Schema Design, Ask Me Anything. I'm Jessie Kissler. I am an engagement manager for the MongoDB professional services team, and I am joined here by Daniel Kupal, our senior data architect, as well as Justin Lebrecq, who is also a senior engagement manager here at MongoDB. Welcome.
Thanks, Jessie.
So Daniel, I will kick it off and let you introduce yourself first.
Well, hi everyone. My name is Daniel Kupal. I'm based on the West Coast. I've been with MongoDB for over 7 years, having different roles, from helping customer and technical service, being in the education team, training, or internal employees on advanced concepts. A lot of that with Justin, which is a lot of fun. And now I'm part of the data architecture team. So along that journey, I've been very passionate about data modeling. So I had the occasion to build presentation and courses on the subject. And that's what is drawing me here today. How about you, Justin?
Everyone, Justin Lebrecq. I'm an engagement manager at MongoDB. What that means practically is my job is to figure out how MongoDB as the company can help you guys, our customers, succeed. Before I was an engagement manager, I was a consulting engineer. So I delivered the types of engagements that I work on now. And I did that for about 4.5 years. I've been with the company now for 5 years. I'm located on the West Coast and have the very thorough knowledge of the product and its underlying workings. One of the roles that I regularly took on was as an instructor for our training curriculums. We do have trainings at MongoDB. And I kind of developed a passion for schema and development and helping customers work through different schema designs. So that's how I got to start with Daniel on different schema presentations and working with all sorts of different ways of presenting data. And that's why I'm here today to answer all of your questions.
Excellent. So let's jump right into it. Daniel, starting with you, how important is it to know the workload of the application to model?
That's a very good question, because I consider that being one of the most important aspects when you do a design for MongoDB. It's kind of the reverse of doing modeling or what we're used to with relational database, where it's very easy to go establish relationship and after that, build a model and go write a code. In MongoDB and most of the NoSQL database, and it's because it's big data, you really need to understand where the bottleneck may be. So identifying your workload to understand if it's going to be more reads or more writes, and what operation is going to be the most important, and what's important for that operation also. How many you're going to get per second, for example, the latency and all that. So describing the workload as your first step is going to get you a much better model usually.
All right, next question, Justin. What should be the granularity of the buckets when using this pattern?
So when we say buckets, we're referring to something called the bucket pattern. And the bucket pattern essentially means arrays, right? MongoDB has a very rich data model available to our users. So what that means practically is that you have the ability to store large chunks of similar data. So when we're talking about buckets, a bucket is a way to store like things. And what that might mean is, say, stock prices. You have stock prices throughout a day, and you're trying to keep all of those different prices together for a similar stock. That would be a bucket. So the question ultimately is, how do we know how many things to put into this array? And this is a really common question, because if you have a lot of data, you might be tempted to put, say, 10 items in an array, or 1,000 items in an array, or 1 million. Right? How do we figure out what number actually makes sense? Really, what should drive your decision is use case. And this is true of all data modeling in MongoDB. This will be a repeated theme as we work through our questions today. Data modeling in MongoDB should start with the use cases and then develop a schema from there, versus what we typically see in relational databases, which would be working on the data model first and then figuring out how to map that directly to your usage. Now, when we're talking about buckets, the use cases are typically things like paging or the top 5 of a thing, right? Things like that. So because of that use case, the question is, what are our typical page sizes? If we're paging in sets of 100, it might make sense to keep a bucket of, say, 1,000. Why 1,000? Well, if you think about what happens when you load a page, you're going to pull a document into memory in the database, and that document will then be transferred over to the application and then presented to the browser. Since that document is now in memory on the database side, and the user is very likely to pull up multiple pages, right? Page 1, page 2, page 3, etc. If you have multiple pages stored in a single bucket, that means that you can reload that exact same document in the case of 100 items per page 10 times before you go through 1,000 items. So that might be a good reason to have 1,000 items in a bucket. It should be some reasonable number. If we're talking about page loads of, say, 25, it might make sense to have 100. So then you can load 4 pages worth of data with a single document. So that's how you decide how large of a bucket should be. Keep in mind that MongoDB imposes a restriction of 16 megabytes on documents. It's a very specific reason, mostly because once you get to that size, documents just become unwieldy to manage and really difficult to load from a application perspective. So we enforce that restriction, and it's very intentional. So keep that in mind when choosing your bucket size.
Okay, and in relation to patterns, Justin, some patterns carry duplications of data. So why is duplication acceptable?
Yeah, so this is very common when we see non-relational schemas. Relational schemas will try to deduplicate data as much as possible. And the reason why is because you have joins to ultimately match that data across multiple tables. In MongoDB, duplicating data makes a lot of sense in certain use cases. There are definitely patterns that use data duplication to the advantage of the application. Again, what we're talking about when we're talking about schema design is use case first. So what that means practically, if you have a page that says, I need a first name and a last name, and general biographical information, and then say another page that displays the first name and last name up in a header, you probably want the first name and last name available to display. So what that means practically is you'll want that data copied multiple places. Now that asks the question, how do we keep this data up to date? This is a challenge for organizations that have trouble keeping track of their data, right? Because that means if you have data duplicated, you might have data in multiple places. This is where features like MongoDB change streams come into play, where you have the ability to subscribe to changes as they occur in the database, and then go update them in places where you find there's a need to have that data changed in multiple places. So lots of different strategies for dealing with duplicate data. We definitely encourage the use of duplicate data where it makes sense. And there are, again, patterns like the extended reference pattern that we can provide information on how to find more about later in the talk. But data duplication will be more common in a document model than it will be in a relational database.
Great, thank you, Justin. Daniel, where could I find more example of the types of patterns, use cases, and how to query them outside of MongoDB University?
Well, it would be easier to answer if there was not the outside of MongoDB University. I will say this is probably where we have our best resources. We have 2 courses. We have a full course on data modeling that cover how to, describe your workload. We go through modeling relationship and all the patterns that we're referring into this talk here. So that's M220. We have another class for people who are coming from the SQL side of things. Let's say you have a lot of experience developing relational database over the years, you're coming to MongoDB. There's a lot of concepts, that are the same at the end. There are things you learn over time. You just have to make the translation to MongoDB. So we've created a very short class of about an hour, 2 hours, M100 that will cover all that. So those are I will say, the 2 best resources. We have a series of blogs that I've done with Ken Alger. Justin also did some, Asya did some. So, there's a lot of resources coming from us. I'm not that aware of other resources from other people, but I'm sure there's some out there. But I would really point you to those first. I think it's pretty, there's a lot, and that's a very good start to understand how to model with MongoDB. As a matter of fact, if you want more information about that, we do have the MongoDB University that has a kind of a virtual stand in one of the other room in this conference. So I will guide you to go see them and ask questions over there.
Great. Daniel, what's the best way to manage schema design modification / evolution?
Well, we do have a pattern for that, and it's described in detail in M320. And the key thing basically is the fact that MongoDB has polymorphism. You can have data that will live in different form. Well, we use that as the base in order to make the transition from one schema to the other one. Your application is able to read documents in both type, and you can migrate at the rate that you want the documents. So using this versioning pattern, you're able to basically do the migration at the rate you want without downtime, and that's a great benefit. And again, I wouldn't have time to go through all the details, but we have a pretty good description in the class for how to do it and learn more about it.
Absolutely, great. Justin, when it comes to hybrid workload, both analytical and transactional, how do you model that? How can it be found into a microservice architecture? And do you prefer to aggregate to use as a database as service, or what would you recommend?
There's a lot to unpack in this question. So so I can probably only cover a small subset of this. When we're talking specifically about microservice architecture, I think the first thing to do is define what a microservices architecture is. When I work with customers, I see different definitions of microservices architectures across the board. Right? It's very common to see microservice architecture as kind of a smaller monolith. It's also very common to see a slim vertical as a microservice architecture, which is typically the standardized definition of a microservices architecture. So really, when it comes to data modeling for kind of a slim vertical model or a slim vertical stack, data is going to be more compact. There's going to be less data shared between microservices. So coming back to the question of what's the best way to model or come up with some sort of architecture for that, when we're talking about kind of that thin definition, really the use case, again, is most important. It comes back to what is the use case, how are we actually transacting on that data, and how does it make sense to keep that data together? When we're talking about a microservices architecture that does have a very narrow vertical, you might be talking about, say, I'm going to go back to my stock example, a broker versus the stock data itself. When you're actually requesting that data from a microservice, you might be hitting a REST endpoint. So depending on what data you expect back from that REST endpoint hit, really dictates how that data should be modeled. So for example, if we're trying to get pricing information, we would be hitting the endpoint for the stock information itself. And you might need information about your broker's name, right? So that would be where you would need data duplication. And then both verticals of your microservices architecture would need to hold that information. When it comes to combining that information together, things like reporting are needed, or asynchronous data processing to bring all that data together in non-REST environments. But again, the whole point of a microservices architecture is to provide sustainability and to provide ease of development. So at the point that you're starting to get cross-data transactions in a microservices architecture, you're kind of moving away from the point of a microservices architecture. So it's important to kind of revisit what are we actually trying to accomplish? Are we using microservices because it's a fancy new buzzword? Or are we using microservices because there's a business need to keep an entire vertical separate so that if one vertical, for example, goes down, our system will still be up and not impacted?
Awesome. Thank you very much, Justin. For those who are viewing, I just would like to remind you to please submit any of your questions into the Q&A tab to the right of the video, as opposed to directly in the chat. So that way there we can make sure that we get all of your questions answered. Daniel, do you think the style of modeling created by William Zola will be a pattern for others, NoSQL such AWS's Dynamo?
So just maybe to put things in context so people don't know about that. This article was written a long time ago at the beginning of MongoDB. There was like a way, there was 6 rules that were put together to describe if you should embed or if you should link document. That was the essence, basically, how to model. And the answer is yes. I think a lot of the things we're doing in MongoDB, the way we model, it's not just because it's MongoDB. Yeah, you have a document model, but even if you're column-based, you have something that's a little bit similar. The thing is, data has changed. Now we have a lot more of very, large amount of data, and modeling needs to be taught differently. Instead of doing a model just with entity, you really need to think about what you're going to be doing with the data. And one of the main rules, which is what is the essence of all those rules and the essence of everything also that we also have in M320 and in 100, is the fact that the data that you're going to be using together should be kept together. That would be the essence, if you want, of one rule on how should you embed it, should you link the data. And that, and after that, using that rule, you look at the queries you have, and then you may have exception. Then you can refine the model. So yeah, to go back to the original 6 rules, they're basically, I will say, a lot of them saying this essence of keep things together that you're going to be using together.
Okay, great. So actually on that topic as well is for data augmentations, right? So for example, the data from different sources for the same product, would you recommend to add those into the same collection embedded or in a separate collection?
We go back to the, I guess, answer for a lot of things. Is you need to understand how you're going to be using your data. If you're going to be doing a lot of queries where you always want, let's say I have like 3 type of data that I wonder if I should put them together. So, true polymorphism, or I should have 3 collection. If most of my query is going to go across the 3 things, I'm pretty better served to put them together. Now, things have changed a little bit in MongoDB. In the past, you didn't really have a choice. It would be much better to put it together, and that was the only choice. If you wanted to query things from different sources, that was they needed to be in one collection. Now, things changed recently, about 2 years ago, when we introduced a union. So now you can take things from one collection and another one and put them together in a single query. But usually, if you do that very often, it's still for performance going to be better if you put the 2 things in the same collection. Again, what you use together should be kept together.
Great. Justin, the maximum size of a BSON file is 16 megabytes. This limitation tends to be a hindrance for developers with big data applications. So is there any way to solve this problem when developing the application?
Yeah, absolutely. When I work with customers, I get this question or very similar question very often. What we typically find is when we're approaching the 16 megabyte document size, there's a data modeling problem. This is mostly true. There are exceptions to this, but these exceptions are rare. If you think about 16 megabytes, what is 16 megabytes? I did this math once, and War and Peace, which is the longest book in the English language, will fit in 16 megabytes 5 times. So what is it that you're doing with 16 megabytes, right? If we're storing binary data, there might be a different strategy that needs to be used. For example, keeping data in an S3 bucket and then referencing that data. If we're talking about sensor data, Chances are we're now using the bucketing pattern. So chances are we're using buckets that are too large. So really, I would take a step back and say, what is it that we're doing with 16 megabytes and why is this document so large? Also think about, once you actually have these large documents, imagine trying to report on that, right? Creating a report and trying to download, say, even 10 16 megabyte documents. That's 160 megabytes that the application has to go load from the database. The network traffic alone will cause that report to be slow. So there's something that we need to take a step back and reevaluate, right? 16 megabytes is a very intentional limit. So it's very unlikely that that will change in the future. Never say never. But when I work with customers and we see that we're approaching the 16 megabyte limit, it's almost always an opportunity to take a step back and reevaluate.
Great. Daniel, which is good? Single schema referring to multiple another schemas or embedded documents in a single schema?
Yes. So this is my interpretation of the question. Basically, should you link to other collections or should you put things together? And again, it goes back to, are you going to read all the information together? And the answer is yes, then it should be in one document. Now, to go a little bit further than that answer we've been giving a few times, when you embed a collection inside another one, you often have like a one-to-many relationship between those. So you're bringing a lot of information inside the main document. The side that you should take is really what you're going to be querying on, what you're going to have information to retrieve this thing, your primary key on one or the other side. Now, you may not need everything from that relationship. So for example, maybe you have a customer and they have like 1,000 of something, log entries or whatever. And when you're making a request on the customer, you're interested in some of the log entries, but not all of them. So that would be a case where you may just want to bring part of it, or you want to leave everything aside because you don't want to be bringing a ton of information. If you put everything together in that document, when you're reading the document in memory, you're going to be bringing a lot more than you need. One thing to understand when you're working with MongoDB is that every time you're reading a document, you're reading the whole document. It's in JSON and it has pointer to go find the rest of the information. So it's not stored by column, the information. It's really the full document that you're bringing in memory. So, and that's also to the point that Justin was mentioning before. When you have a document that is, in the many megabytes, you're bringing probably a lot more in memory than you're going to be using. It's rare that we've seen a customer that store like huge amount of megabytes and they really need all of it at the same time. So that's why breaking in things usually makes for better performance.
Okay, great. This is kind of an open question for whoever would like to take it. As far as when one thread reads a document and is going to make updates, it wants to lock it. Okay, so other threads that read the same document are waiting for it to be unlocked. Does MongoDB have a read lock?
Yeah, so I'll take this one. This is another question that I recommend that we take a step back and try to figure out what we're trying to accomplish. When we're talking about read level locking usually has a specific use case. We're saying typically a queue or some massive amount of multi-threading. When we look at the relational world and you have a read level locks actually can cause problems because you now have either data that is being written to that is outdated, or you're having data being blocked such that you can't read it from another thread, in which case the whole idea of massive parallelism kind of goes out the door. So what are we actually trying to accomplish here? If we're trying to create a queue system, for example, we're not actually looking for read level locks. We're looking for atomic writes, right? Atomic finds and updates, which MongoDB does have. Now, there is definitely a lot that goes into this question because when we're talking about things like queue services, we have two ways to solve problems that typically arise, which are going to be either race conditions or flow control problems. This is where I would say do a deep dive, right? Engage with our professional services team, for example, and work through the problem space to figure out why is it that we need this read level locking. When we talk about the concurrency available in MongoDB in general, MongoDB provides the ability to have massive amounts of concurrency with our model for writing data.
Great. So again, open question for whoever would like to take it, especially with the announcement of 5.0 today and the excitement around sharding. Will there be a possibility to shard by database? So having a use case that will have over 3,000 databases currently running in a replica set, is there a way to do sharding based on namespace?
I can take this one. Well, I'd like to hear a little bit more about what the use case is exactly and what the issue is. The fact that there's 3,000 database, you can distribute 3,000 collection maybe in one database. You can distribute those already on different machine, and you get this kind of sharding. You're going to get locality doing your requests, and everything is going to be on one location. I think what you're asking here is like you want to shard all of those, so that instead of having to shard the 3,000, you just have one command to say anything that will drop in that database will be sharded. That's an interesting concept. I'm not sure, if we see a lot of people doing this kind of thing, obviously we're putting it on the list of things that we should be working on. I haven't seen many requests for this one, but I'll be interested in knowing a little bit more about the use case. I think you can probably do something you need right now by just using the current setting of databases and collection and choosing where thing is going to be.
Yeah, and shameless plug, if this is a multi-tenancy use case, which I would imagine that it is with that many databases, goodness, 5 years ago now, I think I did a talk on multi-tenancy. So please feel free to reference that. And that should also help give you some additional options for how to handle multi-tenancy.
Great. All right, so changing topics to change streams. Could you give or point to an example, Justin, using change streams to keep data in sync, embedding a person's info, but also handling changes to phone numbers?
Yeah, absolutely. So change streams really allows you to do this with the publish subscribe model. You're essentially writing to the database, and change streams allows you to subscribe to a database or a collection and then monitor for changes. So you will need some sort of asynchronous task or subscriber task to handle these updates. One of the interesting problems that we see with high levels of concurrency are race conditions. So what is it that we're actually trying to accomplish with our use case when we have deduplicated data? Well, clearly we're trying to keep data updated across multiple things. Imagine an e-commerce site. And imagine an e-commerce site that has millions upon millions of reviews for its products. Each of those different reviews probably has a name associated with that review. That would be a good example of a case where you would duplicate data, a name, so you don't have to go and find the original name every time that you load a review for a page, right? Maybe using the bucket pattern, for example. When a user updates their name, the use case comes back into play, because the question is, if I update my name at time 0, does it matter that my reviews aren't updated until time 0 plus some number, right? It's asynchronous. We don't necessarily have to go and have all the data updated at exactly the moment that I make my change, especially with something like a name. If we're talking about phone numbers, for example, it's the exact same thing. If we take a step back and ask, what would have happened if I updated my phone number 10 minutes later, right? The users that are then accessing my phone number wouldn't have an updated phone number for 10 minutes. So in that case, when we're talking about asynchronous updates, we actually have more time to work with than most developers typically think of. Most developers are used to the idea that when you update data, all copies of that data must be updated immediately. And that's not necessarily true. So when you have change streams, you can apply a thread, even a single thread, to make it very simple, to monitor changes and then go update, and I'll go back to my example of the review, names and reviews asynchronously and slowly over time. So if somebody goes and looks at a review of mine, say, from a month ago, and that name had been updated, and they see that Justin has a new name, great, they see my new name. If they then go to a separate object or item that then has a review from, say, 5 years ago that hasn't been updated yet, they'll see a different name, but who cares, right? They can click on the link that goes to my profile if they really care, if they want to message me, in which case my profile is probably up to date with my current name. So then they'll get the most current information. So we can utilize tricks like this when it comes to data deduplication and using change streams to subscribe and update data later and asynchronous to really leverage the power of the different models that we have at our disposal.
And Daniel, how does the MongoDB change stream compete in terms of performance with other streaming platforms, such as Redis streams, Kafka, et cetera?
Well, obviously, those are very good products. They're designed to do that. That's their essence. So they're doing a good job. If you're, if it's embedded in your suite of products and you're fine with them, I would say continue using them. The reason we've had our own change set is because there is, as Justin mentioned, there is corner cases. So when it is really important that you catch the things correctly, not just like, okay, I'm going to get a stream and I'll make general decision out of it, but it's really important that I know that the change happened. The MongoDB change stream is going to be more reliable for that. Let me give you an example. If you have anything that points to one of the server and it gets the changes, well, you get information. But what if the server goes down and you were not using majority, you didn't get a commitment majority on that write? Well, maybe it's not something you should not consider. Well, this is something that our change stream is going to take care of. You will only get through your change stream the one that are committed, and that you're not going to lose them. If they get reverted, they're not going to appear in the change stream. So all those corner case between write majority, between things going from one shard to another one, which make maybe a write appear twice in your other system, will be taken care of in MongoDB. So our change stream is going to be much more reliable, I will say, for really to be sure that you're 100% correct in making decision out of these events that you're getting.
Great. Well, thank you both for the change stream conversations. I can actually open it up. So we actually have a question regarding the sharding. Based on my question about sharding on databases, how can we contact one-on-one to elaborate on the use case?
Yeah, I can absolutely help with this. That's my job, right? Is to help you as a customer figure out how MongoDB can help you. We have a professional services team that is available to answer all of these questions and do really in-depth workshops on this type of schema development and schema design. And really our goal is also to enable, right? Is to make sure that your team understands why it is that we make these decisions, how we use case first when determining what kind of schema makes sense. In terms of, can you contact Daniel and myself directly? We get a lot of email. I apologize. We don't necessarily have time to answer everybody's questions offline, but feel free to contact our professional services team and we'll make sure to set up some time to work through your use case and figure out how MongoDB can help.
I will attest to Justin not only being busy in his own day-to-day, but also helping onboard a lot of the newer engagement managers, such as myself, and sharing the wealth and knowledge that he has experienced. So yes, thank you, Justin, for always being willing to share your knowledge.
Yeah. Thank you.
All right, what features does Mongo have for achieving immediate consistency with the convention of having duplicated data? What has been the observed performance versus traditional SQL solutions?
I guess
I can take it.
Yeah.
MongoDB, for those of you who don't know, MongoDB has transaction. So you can use them if you're going to write to many documents. You can open a transaction exactly like what you would be doing in the relational world. You can open a transaction, the syntax is the same, write the documents, everything goes in or nothing goes in. So it's very similar. Now, that said, even if we've seen very good performance, better than we expected at the beginning, in the world of big data, you probably don't want to open 10,000 transactions per second. The system is not going to scale. If you're doing a ton of transactions, you probably want to go back and look at your model. There probably something wrong. It probably means that you're writing things, together at the same time that need to be, written at one time. And also, performance-wise, you think about it, every time you're doing writes, it's expensive. So if for every operation you need to do like 3 writes, and now you need to commit, you're pretty better off putting the 3 things in one document and doing 1 write. You're going to be dividing by 3 the number of writes, and you're going to be needing much less resources to satisfy the need of that workload.
Okay, great. Let's see here. So how would you model analytics data over time, which has a metric with submetrics? You could also think of a sensor with areas to measure where these areas have further measurements.
Yeah, that's actually a really interesting use case. I think that the domain is important here. What is it that we're doing with this data once we actually record it? We could, for example, keep the metric with its submetrics, but realistically, when we're trying to utilize this data, chances are we're using either the submetrics or the metrics themselves, right? We're probably not using both of them at the same time. And if we are, we're probably not using them for the exact same thing. If one metric relies on another, then I would say, use and store the calculated value in addition to the submetric. So then you don't have to go and worry about using both of them at the same time. When we're talking about the domain, it might make sense to actually separate the submetric in such a way that the metric itself is part of maybe the underscore ID, for example. That would obviously then still have to reference the device that's recording this metric, depending on what our use case is. So there are a lot of different possibilities here. I think that each document should represent something that really is useful to the end result. So I guess to really answer the question, does it make sense to store the submetrics with the metric in the first place? Or what are we really trying to accomplish? Are we trying to accomplish some sort of calculated value versus actually needing to keep it together?
All right, great. So with the clock winding down, I think, Justin, an important aspect that you have continuously addressed is actually both of you is kind of taking that step back and understanding what exactly is the use case, right? What is the point in having that ideology when creating your schema? So one of the last questions that we can address here and open for whoever would like to take it. So before 5.0, which time series database did Mongo use for Atlas and other internal MongoDB products?
MongoDB. We use MongoDB. Even without the time series database, there are patterns that exist to help with this. MongoDB is a great flexible data store for all different types of data, including time series data historically. The way that we stored this data, it was a combination of bucket pattern with calculated metrics, and granularity of things like graphs is really something you can take into account when modeling that data manually. What are the granularities that you're trying to display in your graphs, and then store the data either in the granularity that you need or in a very similar granularity so that you can calculate your graphs very, very quickly. So we use MongoDB.
Awesome. All right, and then the final question. How do we approach data modeling in MongoDB? What are the best data modeling tools currently available in the market that support MongoDB?
That's a good question. Daniel, do you have a
question? There is one product out there that lets you, if you're talking about like graphical representation, I will give a plug to Accolade here. They do have a way to represent MongoDB document being embedded. They have a very good reverse engineering model. So if you already have documents, it will extract the model out of it. So that's one that I know. I've used it a few times.
Yeah, this is a tough one. We work very regularly with customers to do exactly this manually most of the time, not because there isn't software to do this, but because I think when we're developing the developers need to have a very thorough understanding of their data set. So having automatic processes represent this data might be kind of counterintuitive. There are absolutely reasons to have this done automatically. Don't get me wrong, I'm not trying to say that there aren't. But we want to make sure that, again, the use case comes first and that modeling data is really well understood by the people that have to implement it, because ultimately that's the goal, right? Is to get things to market quickly, to use the document model to its maximum advantage. And to do that, understanding the data model is critical.
All right. Well, Daniel and Justin, thank you very much for your time.
Thanks, Jesse.
Yeah, thank you, everybody.